Silly Putty is a ubiquitous children's toy dating back to the 1940s. It was accidentally created during World War II when the US government was seeking a substitute for rubber. It was in the 1960s when it started being mass marketed all around the world as the toy we know today.
You can buy Silly Putty for $1 wherever toys are sold. And remember, nothing else is Silly Putty.
Chemically, Silly Putty is made with a whole host of different compounds, usually containing silicon, like dimethylsiloxane, which is polymerized into polydimethylsiloxane. This polymer, however, can be mimicked out of common household items, and this is what we'll be exploring in this video. For this synthesis, all you need is some borax, Elmer's glue, and distilled water, all of which you can buy from Walmart for just a few dollars each. All this other stuff is merely for cosmetic purposes, and thus is optional. I chose to go with the clear glue because I was hoping it would give me more control over the appearance of the final product, but white glue will work too. Before I can start making the putty, I have to make a 4% borax solution. I do this by mixing 4 grams of borax and 96 grams of distilled water in a beaker. I stir the solution with a stirring rod, but after a minute of stirring, I realized this is going to take a while, so I opt for magnetic stirring instead. It turns out it took much longer than I expected. I even had to turn on heating to make it go faster, but eventually all the borax dissolves. With that out of the way, I start making the putty by adding 20 milliliters of glue to a beaker, followed by 20 milliliters of distilled water. Because the solution is so thick, I'm forced to use a stirring rod instead of magnetic stirring. When I get a homogeneous mixture, I slowly add 2 milliliters of borax solution at a time for a total of 8 milliliters. With each addition, I can feel the solution getting much more viscous as I stir, which is telling me the silly putty is forming. What's going on here is known as cross-linking. The Elmer's glue is an aqueous solution of polyvinyl acetate, and when mixed with borax, the long chains of this polymer are connected together. This makes the molecule as a whole much more rigid than before. The more borax is added, the more rigid the new molecule becomes. This increase in rigidity is why the solution becomes so viscous and why the silly putty forms. You can visualize it like this. Think of these 2 paperclip chains as the long polymers of polyvinyl acetate in solution. Like this, it isn't too special. They can move and slide like molecules do, but once I start cross-linking them together, the whole thing becomes a lot more rigid and difficult to separate. Anyway, once I've added all the borax solution, I pull out my stirring rod to notice it's covered in goop. I scoop out all the silly putty with my hands and see what I've created. At first, it's as sticky as the glue was, but after kneading it in my hands for a bit, I'm left with my final product. I redo the procedure a few times, each time adding a different dye. I happen to have red, blue, and pink, but the pink looks red because it's super concentrated. Don't bother adding indicator. It doesn't do anything, even though borax solution is slightly basic. In one of the red ones, I added a whole bunch of iron flakes. I was hoping this would make the gel react to magnets, but there's too little of it to matter. I still think it looks better than the standard red one though. Anyway, regardless of what I put in it, it all feels identical and has a consistency more like gelatin than silly putty, but I start comparing the two anyway. That old 1960s ad made 3 claims I'll test.
If you pull it so, it'll go forever, like taffy. But if you give it a sharp tug, it'll break like a biscuit. Now, when you make silly putty round and drop it, it'll bounce higher than a rubber ball. And here's something else you can do with silly putty. Flatten it, press a picture in your newspaper, lift it, stretch it this way and that, and you'll get something that's really funny.
Immediately, I can tell it doesn't stretch remotely as well as the silly putty. Trying to make it stretch simply makes the polymer burst into pieces. This makes sense because the crosslinks in the silly putty are formed by covalent bonds, while the crosslinks in the gel are made with hydrogen bonds, which are a lot weaker. On the bright side, it breaks like a biscuit just about as well as silly putty. In terms of bouncing, the two seem comparable at first, but after a few more trials, it's pretty obvious the silly putty is a lot better at bouncing. When I throw them both really hard against the table, the gel simply bursts into a million pieces. On the other hand, the silly putty keeps bouncing. When it comes to copying images from newspaper, it turns out both substances fail. I can press as hard as possible on the paper, but no matter what, neither copies anything. I even tried different types of paper. This is expected though, because the composition of ink has changed a lot from the 60s. Even though it doesn't resemble the silly putty all that well, the gel is really interesting in its own right. It seems to act like a very viscous liquid on long time intervals, and an elastic solid on short time intervals. This property is known as viscoelasticity. For example, when I break it up into a bunch of pieces, it will slowly melt together and form this neat looking puddle. For better or for worse, it does this a lot better than the silly putty. If I put a whole bunch of gel in a beaker and put a quarter on top, the quarter will slowly sink to the bottom. To give you an idea of how long this took, my camera died twice in the making of this time lapse. Overall, what I created wasn't a perfect imitation of silly putty, but it was still fun to play with. Based on what I've seen, it's more accurate to label this as slime than putty. You might be able to make a better clone by tweaking the recipe, but that's beyond the scope of this video. I might try making more polymers in the future, but regardless, thanks for watching and have a great day.